Hello, everybody. Thanks for coming to this session on being more productive with the AWS SDK for Java. My name is Jason Fulgham. I'm a Java developer with AWS Developer Resources. I've been working with Amazon for about 7 years now and have been lucky enough to work with AWS for about the past 4 years, building tools for Java developers such as the AWS SDK for Java and the AWS Toolkit for Eclipse. We've only got one goal for the next hour that we have together, so it should be pretty simple. I'm going to show you guys how to do more with the SDK in less time and with less code that you guys have to write, test, debug, and maintain. I know that sounds like a tall order, but we're going to be able to easily accomplish that by taking a tour through some of the more advanced features in the SDK. For the purpose of this talk, we're going to kind of split the SDK into 2 layers. And we're starting at this bottom layer of the SDK where we provide support for over 24 different AWS services. Each one of those services has a corresponding client class, and that client provides a direct mapping of the services API. It's essentially a Java binding for the services API. And because it's a one-to-one mapping, anything that the service provides, any functionality, any feature, is really easy to exercise through these clients. And of course, beyond just the binding of the services API, these clients also provide a lot of best practices that we've learned over the years. So things like secure request authentication for the various AWS signing protocols, super fast and efficient response and request processing is one of the things that we're always keeping an eye on. And also things like response handling, error responses, throttling, making sure we're retrying those and backing off appropriately between retries. But where we're really going to be spending our time in this session is on the higher level of the SDK, this upper level. And all of this is built on top of the lower level clients that we just saw. So any of this is possible with the lower level clients, but using these higher level APIs is how you can really gain a lot more productivity with the SDK. The big difference between the low level clients and these higher level APIs is that the low level clients try to map the services API directly, whereas these higher level APIs come at the problem from a different direction and try to solve one really common scenario that developers have to face when building an application on AWS and make it as simple as possible. So unfortunately, we don't have time to go through all the high level APIs, but we're going to give you a little tour and go through 3 or 4 of them. Just to give you an idea of some of the things that's exposed through these higher level APIs. There's support for working with S3 data, uploading and downloading data. We'll get to play with that today. There's support for working with data in DynamoDB, which we'll also get to play with. There's some encryption tools that are really neat that we'll get to see too. And some of the stuff that we won't see is, for example, the policy API. Some of you might have worked with policies already for bucket lifecycles or for IAM users. And if you have, you probably know that it's kind of painful to work with these big, long blobs of JSON and build those up manually. So the policy API gives you a programmatic way to build those up. And it's just kind of a little more expressive than having those big blobs of text. The big thing really to take away from this slide, though, is that if you know what's in these high-level APIs and you know how to leverage them, then you can really be a lot more productive with the SDK. It's going to save you a lot of time and a lot of code as well. So let's get started with the first higher-level API that we're looking at today, and this is Amazon S3 TransferManager. Have any of you already used TransferManager before? Heard of it? Awesome, cool. So we got lots of new people to learn TransferManager. TransferManager provides asynchronous management of your uploads and downloads between your application and Amazon S3. And in addition to that kind of nice, really easy to use asynchronous interface, you also get these really nice management tools for checking the progress of your transfers, being updated as your transfer progresses along or changes state, the ability to cancel transfers, a lot of things that really fit nicely into well-behaving applications. I wanted to start with TransferManager for a couple different reasons. The first one is that this is one of the APIs that we just use a ton, both inside of Amazon and inside of AWS Developer Resources. It's really easy to use. The asynchronous management, the fact that you can start a transfer and it will run in a background pool of threads, just fits so nicely into so many different types of applications. For example, one of the big UIs that we maintain on my team is the AWS Toolkit for Eclipse. And all the work we do with S3 to transfer files, to show progress dialogues, allow users to cancel the transfers, all of that comes directly from TransferManager and really makes it easy to use in that context. The second reason that I wanted to start with TransferManager is that it's a good example of how these higher-level APIs really take a complex problem and put a really simple interface on it. So just moving bits between your application and S3 seems like something that's pretty simple at first, but the deeper you get into the problem, the more you find that there are some interesting gotchas along the way and some error cases that maybe don't come up that often but are really critical to be handled correctly if you want a well-behaving application. And even more importantly, there are some opportunities for optimizations. One of those examples is the way that we can update or upload data to Amazon S3. There's a couple different approaches in the S3 API for uploading the data. One of them is the traditional single-part upload, and this newer one is multi-part upload. Some of you guys might have already heard of the multi-part upload process and single-part uploads. Both of those have really great advantages, and they're more appropriate for different scenarios, for different types of uploads. But it's a little tricky to know exactly when you should be using which process. And that's a great example of something that TransferManager handles completely seamlessly for you. The interface to TransferManager is really as simple as upload and download. And underneath that, you guys are getting all this great error handling. You're getting this great selection of the right algorithm that's going to be best for the data you're uploading. And along with that, you get some better error handling and some of these throughput optimizations. So whenever possible, TransferManager is going to break your upload up into individual parts and use the multi-part upload process when it makes sense for your upload data. And that has a couple of really nice effects. The first one being is that we can often transfer those multiple parts in parallel to give your application better throughput. And if you're uploading maybe a 5 gigabyte file, for example, and you have a socket problem or an I/O problem along the way, you don't have to trash all of the work that you've uploaded. You get to just upload or retransmit that one individual part. So again, you're going to get better error handling. You're going to get better performance from using TransferManager. So now that you guys know what TransferManager is, let's jump over to Eclipse and play with it a little bit. Okay, so over in Eclipse here, we've got a really simple Swing application. This is actually based on one of the samples that we ship with the SDK. So if you guys think this is interesting, you want to know more about TransferManager, you want to play with it more, just download the SDK zip, check out the samples directory, and you can find pretty much this exact same code. And you can play with TransferManager some more and see some of these features that we're playing with. I'm going to go ahead and run this app just so that we can see what it does, and then we'll hop into the code and see how it does it. Oops. So we've got our little Swing window here, we've got a progress bar, and we've got a button. The button's hooked up to a file chooser. Lets us pick a file, and then as soon as we select this file, TransferManager is going to start uploading that to Amazon S3. Now, I've got some wire logging turned on, so you guys can see down in the console view that we're actually transferring data. But you guys probably noticed that this progress bar isn't filling up yet. That's one of the tasks we're going to work on in just a couple minutes and see if we can hook that up using the TransferManager APIs. So down here in our code that's using TransferManager, before we get to TransferManager, I want to take a quick sidetrack and talk a little bit about credentials and credential management. There are some nice tools in the SDK that can make managing your credentials a little bit easier and more consistent among your different applications. And I want to make sure you guys have seen those and know some of their benefits. So in this example, you can see we're using a class path properties file credentials provider. While that is a mouthful to say, it's really very easy to use. And it means that a properties file is going to be loaded from the class path with your credentials. So this is an example of a very easy-to-use implementation of a credentials provider. It's already in the SDK for you to use. If you guys have different stages, for example, maybe gamma, beta, prod stages for your applications, you probably want to use different credentials in those stages to keep your application and your data isolated. This would be really easy to have your deployment process slide in different properties files on your application's class path to get that nice separation and have your credentials just pulled in pretty easily. But if you don't like this one, there's a number of different credentials providers. So this is the main interface, AWS Credentials Provider, and you can see in type hierarchy view, these are all the different implementations that are provided by the SDK. We already saw class path properties file, credentials provider. There are implementations to load credentials from the OS's environment variables, from the JVM system properties, and there's also this credentials provider chain, which is used by default in all the default constructors for the SDK clients that we saw in the lower level. It's going to first attempt to look in some of these system properties, environment variables, and then the last step in the chain is probably my favorite credentials provider. This is one of the ones that we've recently added to the SDK that will load your credentials directly from EC2 instance that you're running on. So some of you might already know about these IAM roles in EC2, where you can have EC2 deliver your credentials securely to the instances that you're running on. It's a really fantastic way to distribute your credentials, especially if you're running your application on EC2 instances. Your credentials are there already waiting for your application to pick them up. All of the AWS SDKs will load them seamlessly without developers really having to do anything or think about credentials. And of course, if none of these credential providers do the right strategy that you guys are looking for, it's very easy to implement this interface yourself. And in fact, that's exactly what we do inside Amazon. We have a standard implementation of credentials provider. It's been blessed by security. It's consistent among all the applications that our developers use internally. And it means that developers don't ever have to worry about credentials. It's all integrated with our in-house key management systems. Security's happy because everyone's using the blessed security version, and it's really just one less thing to worry about in the applications. So now that we know how to get our credentials, in order to use TransferManager, we just construct a new instance, passing in those credentials. Some of you can probably read this note. It's important to realize that TransferManager manages this pool of threads for you. So you wouldn't want to create a new TransferManager instance for every upload you're going to do because that's going to be spinning up these new thread pools and probably a little wasteful. For most applications, you can simply share one instance of TransferManager. You could certainly use multiple. We have some applications that partition resources a little bit and use multiple instances of TransferManager. But for the most part, and in our app, we're just going to use one instance. So we create our TransferManager object, and then we reference it down here in our button listener. So in our button handler, you can see we are opening a file chooser, letting the user pick a file, and then we are just calling the upload operation. We create this put object request, specify the S3 bucket where we want to upload our object to, the key under which we want to store it in S3, and the file we want to upload. And then after that, we just pass it to TransferManager and tell TransferManager to start uploading it. Now, I mentioned before the asynchronous nature of TransferManager. And so that means that this upload operation is going to immediately return us an upload object. It's not going to sit there and block and wait for the upload to actually transfer. And we're not using this upload anywhere in our code right now, but we're going to explore the API a little bit and see if we can hook up that progress bar using it. So this instance right here of upload is just an instance of the upload interface. And you guys can see that there's really not a whole lot in this interface. So the vast majority of the functionality is all contained in the transfer interface, which gives you the ability to manage uploads and downloads in the same way, which is nice. So let's hop over to transfer and see what we can do with uploads and downloads. So this is the transfer interface. The very first thing we see is that we have some information about what state the transfer is in. There's enumeration for different states. We can see if the transfer is waiting. Maybe the thread pool that we're sharing is full of other resources, other transfers already in progress. So maybe our upload is waiting, or it could be in progress, completed, canceled, or failed. If our upload hasn't finished yet, we can ask if it's done. And if not, we can block if we want to and wait for its completion. There's another method if we're just concerned with getting the actual exception that happens. We just want to block and wait for that. That's available too. and then some metadata and description. We talked about state. But where I really want to show you guys and kind of play with in this demo is these progress tools, because I think this has certainly been really useful for us, and I think can be useful in your applications as well. So these last three methods all deal with progress for transfers. And the first two simply deal with adding and removing progress listeners. And this progress listener interface is, again, super simple. It's just got one method for you to implement. And this is going to give you a really easy callback from the SDK or from TransferManager to let you know your transfer is moving along, making different progress events. So as your transfer progresses along, your implementation is going to get calls from TransferManager. And you've got the ability to tell what's going on. You can tell if your transfer has started, if it's failed or started, or even canceled. You also have some nice granularity into those multi-part uploads that we talked about. So if you do want to see when individual parts are making progress, you can see that here as well. And one of the big pieces of information that you get from progress event is how many bytes have been transferred. And this is going to be essentially the delta of bytes that have transferred, or how many bytes have been transferred since you were last notified about a progress event. So that was progress event we just saw, and this progress listener interface where we can register to receive these callbacks as our transfers progress along. So those are the first two methods we just saw. This last method lets us directly ask transfers for their progress. And this transfer progress just tells us how many bytes have been transferred so far and how many bytes are involved in this transfer total. And then there's a nice little utility method down here to get a quick percentage. So now that we've seen progress listener, progress events, and how we can ask uploads for their progress, let's go back to our demo code and see if we can hook up that progress bar. So we saw how we can add those progress listeners directly to the transfer objects. And if we know we want that ahead of time, we can also pass those progress listeners in through this put object request. So we're just going to set a progress listener. And I'm just going to create a new anonymous inner type for progress listener. And then inside this progress change method, this is our hook into the progress changes of those transfers. Now, all we really care to do is update that the progress bar. So we're just going to set the value. And we could grab this information from the progress event and keep track of it over time. But it's really easy just to ask the upload how far it is. So we've got a reference to our upload, and we will just get the progress and get the percent transferred. And that's really all we have to do to hook up that progress bar. So we've added a progress listener implementation that's going to get callbacks as the progress moves along for the transfer. And every time the transfer progresses, we're just going to update the progress bar with the progress. So now that we've added that, let's run our code again and see how it does. We'll just select the same file that we were using before. We should still see our output going along in the console window, and then as expected, we also see our progress bar filling up correctly. So really, with just a couple lines of code, we're able to get that information from the progress, get those callbacks from TransferManager letting us know that the progress is moving along, and report that through the UI. There are still a few more features in TransferManager that we're not going to play with today. There are some more advanced features around recursive file uploads and downloads between your application and S3. I definitely encourage you guys to play with TransferManager. The UI or the interface is super easy to use. It's essentially upload and download, and that's it. So definitely check out TransferManager. It's one of our favorite APIs, and I hope you guys enjoy playing with it too.
So can you set the content type? How do you do that?
Oh yeah, actually. So if we go down to this put object request, if you've used the lower level S3 client, this is actually the same object from there. So we can set our the metadata, the object metadata, and that has all that information, content type, content disposition, any custom user metadata that you guys want to store with the object, you still have access to do all that as well. Okay, so that was TransferManager, our first API. The next one that we're going to be looking at is another S3 utility that we use really heavily as well, the Amazon S3 Encryption Client. The Amazon S3 Encryption Client is really an industrial-strength client-side encryption tool that has the identical interface as the Amazon S3 client. So to break that down, I call this industrial strength because this is our standard solution for encrypting data that we store at Amazon. If we're dealing with sensitive data that needs to be encrypted and we're storing it in S3 and a Java application, this is exactly the same code that we're using at Amazon. And we pump tons of data through this client. The next point about this was that this is a client-side tool, and that's really important to understand is that all the encryption and decryption is happening on the fly on the client side. So that gives you a really strong security guarantee knowing that your unencrypted sensitive data is never leaving your application. And finally, the last point about encryption, the encryption client, is that its interface is exactly the same as the S3 client. It really implements the same interface, Amazon S3. If you know how to use the S3 client, you can use the encryption client already. And just to demonstrate that a little bit more, we've got a little demo here where we are working just with the regular S3 client. This, again, is based on one of the samples from the SDK. If you're curious about this, open up the samples directory in the SDK, and you can play with this one some more. All we're doing here is creating a bucket, uploading some of our super secret sensitive data from AWS, and then downloading it again. So this is starting off just with the regular Amazon S3 client. I'll go ahead and run this, and we can check out the console output again. And we're getting this output on the console from Apache HTTP client's wire logging, which is extremely helpful if you do want to see more about the messages being passed between the AWS SDK and AWS and see exactly the headers, payloads that are being passed along. If you're curious about it, you want to know more, or you're having some sort of problem, you think your request isn't being processed correctly, turning on that logging is really easy with the SDK, and it's a great tool to see exactly what's happening, the interaction. So we've got all our payloads here. We can see our super secret sensitive AWS data here being sent across the wire. Now, I don't want any of you guys to think for a minute that we're just sending this in the clear. This is all still going over an SSL connection. So it's not like we're just transmitting this data over in clear text. All the SDKs default to sending everything over HTTPS, so you do have that level of security built in. But I'm willing to bet that every single one of you has some sort of data that you guys would feel more comfortable with, or your customers would at least, if it were being handled with a stronger security guarantee, guaranteeing that your unencrypted data is never even leaving your application. There's certainly a whole number of things that could happen, not the least of which is human error, where if maybe a team member messes up permissions and suddenly your data in S3 is world readable, providing this extra layer of transformation is a great way to mitigate those risks. So that was the S3 client. Let's take a look at how we change this to the encryption client. And really all I'm going to do is change this constructor. So the first thing I have to do is, of course, make it use the S3 encryption client. We're still going to pass in our credentials, but we do have to pass in one more piece of information. And this is just the encryption materials that are driving the encryption process. I'm going to get into a lot more detail on how these encryption materials are used, but for now, you can just know that this is an asymmetric key pair that is driving the encryption process. So we've just changed this one constructor. I'll run the code again, and we can see how the output changes. And so before, where we directly saw our Amazon AWS information, now we can see that it's all being encrypted. And the great thing about this is that it's really the exact same thing as the S3 client API. Your application never even needs to know that it's working with the encryption client. It just uses that interface, and all this encryption and decryption happens on the fly automatically. So now let's talk a little bit more about how the encryption client works, where those encryption materials come from, and the process that's going on beneath the API. But before we can talk too much about it, I just want to take 30 seconds to review asymmetric encryption and symmetric encryption, in case you guys haven't touched that for a while. Symmetric key encryption, of course, you have one symmetric key. use it to encrypt your data, and then going the other way, use it to decrypt your data. So that's kind of the symmetric nature of it. Asymmetric key encryption, of course, has two parts, your public key and your private key. You use one to encrypt, and then you have to have the other part to decrypt. And we're using a pretty common cryptography approach here called envelope encryption, where we're going to combine symmetric key encryption and asymmetric key encryption to kind of get the best of both worlds. Symmetric key encryption has these really great properties where it's going to be really fast. And we really want that because we're uploading lots of data to S3. We can't buffer all that in memory and do the encryption in memory. We've got to do it all on the fly. So that's why we like the symmetric encryption for that. And asymmetric encryption just has some really nice properties around splitting up that key pair into two parts so that you can give one person the ability to encrypt but not decrypt, and vice versa. So inside your application, you've really got two things that you're responsible for. It's, of course, your unencrypted sensitive data that you want to protect, and the master key that you're using to drive this encryption process. And like I said before, this master key is your encryption materials. It's typically an asymmetric key, although there are options to use other types of keys in the SDK. But we're not actually going to use that key to encrypt our data, as you're going to see in a minute. What we're going to do instead is for every upload that you're using the S3 encryption client, for every object you're uploading to S3 and encrypting, we're going to generate a one-time use symmetric key that we call the envelope encryption key. And this is actually what we're going to use to encrypt our data as it goes up to S3. And that's where we get the nice benefits of symmetric key encryption, because we're going to be able to do this on the fly very quickly. So the envelope key encrypts our data. Data is stored in S3 encrypted. And then we have to deal with this envelope key somehow. So we're going to store the envelope key in S3 alongside the object as object metadata. But we don't want to store it unencrypted, of course, so that's where the master encryption key comes in. And we are using the asymmetric master encryption key to encrypt the envelope key and store that with the object metadata. So if you kind of think through that in reverse, the first thing we do is download the object metadata when we want to decrypt an object. We use our master key to decrypt the envelope key. And then once we have the envelope key, we just stream down the data and decrypt it on the fly. Having this kind of combination, this abstraction on top of the key that you're using to encrypt the data also has some other nice properties. If for some reason your master encryption materials are compromised, then you don't have to necessarily pull down all of your objects or all of your gigs and gigs of data that are encrypted, decrypt them, and then re-encrypt them with a new key. Instead, if you know that just the master key was compromised, you can download the object metadata to get the encrypted envelope key, just decrypt the envelope key, and then re-encrypt that with a new set of credentials. Or if you have key rotation policies at your company, this is another kind of nice advantage of that extra layer of abstraction on top. There's a little bit more to the encryption client, of course, than we're not covering today. There are some great articles on our site that go into more depth on where these encryption materials come from and explain some hooks that you guys can use to integrate with any in-house key management systems. So again, just like we saw for credentials, this is exactly what we do at Amazon. We have one system internally that manages all of our secret keys, and developers don't ever really have to touch secret keys. So again, developers are happy because this is easy for them to deal with, and security is happy because developers aren't touching the encryption keys. So if you are interested in more of the encryption key or encryption process, definitely find the article on the S3 client on our site, and it goes into a lot more detail about implementing that and integrating it with systems. Yes?
If you're going to do client-side encryption, do you give up the ability to use the MD5
The MD5 e-tags, it gets a little bit complicated. Yeah, that's a good question. We will store the original MD5 for you as part of the object metadata. So if you are using that and you want to get those client-side integrity checks when you download, you can still use that information. The SDK will still use that information to do the client-side checks. So you're right, the data is transforming, so the e-tag has changed, but we are keeping some of the original MD5 for the unencrypted data around for you for some of the same purposes that people use the e-tags. If you have a different use case than just the client-side verification, happy to talk about it afterwards. I know people are using the e-tags for all sorts of stuff. No problem. I'm sure that by this point in the conference, every single one of you has heard about DynamoDB. It's our brand new NoSQL fully managed database service that gives you fast and predictable performance. And this is one of the newer pieces of the SDK, one of the newer high-level APIs. And it's one of the ones that we have been particularly excited about. We've had a chance to play with Dynamo during its development, not only our team, but all around Amazon, and build lots of different applications and see how they perform, how we want to use them in our Java applications. And we very quickly noticed that we were building a lot of the same code over and over to marshal the data from our Java objects into DynamoDB objects. So for any of you that have ever used Hibernate or any other JPA implementation, I'm sure you already know where I'm going. This is going to be instantly familiar to you. This DynamoDB ObjectMapper in the SDK allows you to annotate your Java objects and then use this DynamoDB Mapper class to save them into Dynamo, to load them, to run scans and queries, and use a lot of nice features from Dynamo. So here we've got another piece of sample code. We've got an inner type called user that we've annotated already for use with the object mapper. And then down here, we've got a main method where we're creating some of those user objects, we're saving them to Dynamo, and showing how we use that DynamoDB Mapper class. So let's start with user and show how we get this class ready for use for the object mapper. And all it takes is really knowing 4 different annotations. That's all we have to use in order to annotate this class and get it ready to go with the mapper. The first annotation we need is DynamoDB table. This is required for any class that you want to use with a mapper. You just need to specify the table name where these entities are being stored and loaded from. And these next 2 annotations are both on the ID member of this class. Now, when you create a table with Dynamo, this is not like a traditional relational database table where you have to fully specify your schema up front. Instead, all you have to specify up front are your key attributes, so that Dynamo can set up an index for those, and so that the SDK knows how to quickly look up these entities. So we're just telling the SDK here that our ID member is our hash key. Hash key is essentially a unique primary key for our entity. There's also range keys supported by DynamoDB and supported by the object mapper, but we're not using those in this example. So this first annotation, DynamoDB hash key, lets the mapper know this is our hash key attribute. And this next one is not actually required. It just is kind of a little more convenient. It tells the SDK, go ahead and fill in on the client side a unique value for this ID so that we don't have to worry about it in our code. And then this fourth annotation that we need is DynamoDB attribute. And we just slap this on any of the members that we actually want included in the marshaling when data from Java is loaded into DynamoDB and vice versa. So that's really all it took, is 4 annotations to get this class ready to use with the DynamoDB mapper. Going down into our main method where we're using the mapper, you can see, of course, we always start by getting our credentials. In this example, there's a number of ways to create these DynamoDB mappers. We're creating a client because we're using it to also make sure our table is created. And then we're passing it into the mapper object. So once we have this mapper object, all we have to do is call save and load to save these objects into Dynamo. So you can see we're creating a user, we're saving him in, and printing out the user we created. Then we're loading him and showing that it's actually all the same data. So we'll open up our console here and run this. So as you can see, the same data that we're pushing into Dynamo, we're loading into the same entity into a new variable and showing that it's all the same data coming back. So working with this really simplified a lot of those applications that we were writing inside when we were playing with Dynamo. You kind of have this common pattern of storing Java objects into DynamoDB table, and it's just really convenient to use instead of going down to the low-level client all the time. So this isn't all that the object mapper does. You can also run scans on your data. You can query your data. And there's a couple more attributes, including one more that I want to show you guys. So this pattern that we're using here is we're loading an entity from Dynamo, we're altering it locally, and then we are saving it back to Dynamo. And one of the worst things that could happen, what we really don't want to have happen, is for two pieces of code to be editing the same entity at the same time. And essentially, it's a race condition where one piece of code gets to save its changes back, and the other piece of code gets to save its changes and overwrite the first piece, potentially. So as you can imagine, this would be a nightmare to debug. There's not going to be any logging information or any really clues about what happened other than strange behavior in your system. What we really want is for the system to somehow tell us that we're trying to save back the stale data, that we made alterations or changes to an older version of an entity, and that we don't want to save it back. We want to be stopped somehow. So the object mapper provides another annotation we can use to enable this optimistic locking feature. And I'm going to see if we can add that real quick to our users class. So we're going to add a new field here, a new member called version. And I'm going to generate a getter and a setter for version. Then all we have to do is use this DynamoDB version attribute annotation. And that tells the object mapper that this is the field we're using for optimistic locking. And whenever we try to save entities back to DynamoDB, the SDK is going to alter the request a little bit so that we send along this conditional clause that says only apply this update, only apply these changes to this data if this is still the latest version of the data. So let's try to trigger this now that we've turned on this optimistic locking feature. And this will be a little artificial for this demo. You guys can imagine maybe we have multiple threads or different applications that are editing the same entity at once. But let's say our first piece of code is changing the state of this entity. We've already got these two variables, user and new user, that reference the same entity, so we'll use them. And this first piece of code is changing this user to an invalid status. And now let's say we've got another application or a thread somewhere that is working on the same entity at the same time and has a version of the entity before this status change has been made. So he's changing this guy's name to Bob, let's say, and then he's trying to save this object back. So without this optimistic locking feature, this is a race condition. One of these guys is going to win, one's going to lose. This first guy is going to make his update to change the status, and then the second guy is going to come along, and he's got this older version before the status change, and he's just going to blow away the first change that was made. So you can imagine that just being a nightmare to debug. But with optimistic locking turned on, when we run this code, instead we're going to get an error from the SDK. So you can see we got this exception returned from DynamoDB. This is on line 98, and that's when we try to save this second piece of data. So this is when we have stale data, we've made changes to it, the data in DynamoDB is no longer the same version as this one, and that's when DynamoDB is going to give us this error message of conditional check failed exception. And that's our applications queue that we're not working with the most recent data anymore, that we need to drop this, check out the latest version, apply our edits again, and then attempt to make that change again. So that is everything we have for Dynamo. There's a couple more features in there. Also another great API in the SDK. I would definitely encourage you to check this one out, especially if you're curious about Dynamo. It's a really great way to get started with Dynamo and play with it and build something really quickly, too.
So why do you annotate the getters and setters as opposed to the actual field?
That's a good question. I think we basically just followed some of the other examples that we were seeing out with other third-party tools. Annotating the getter allows you to do maybe virtual members if you don't have a member object that backs it, or if you want to do some sort of data transformation on it. Good question. And then last but certainly not least, oh, sorry, yes, sir. Yeah, of course.
Any support at all for transactions?
Dynamo does not have support for transactions right now. Yes, sir.
It's essentially the same as we saw this morning for the Android.
Awesome. Yes, yeah,
Use exactly the same class both in my desktop client and my mobile client.
that's exactly correct. Yeah, the Android SDK. The question was, this demo is showed for Android. Is the code compatible? Do we work with the Android DynamoMapper the same way that we do with the Java SDK? And the answer is yes. The Android SDK is kind of a transformation of the Java SDK. It's just changed ever so slightly so it fits in with some of the libraries that are already in Android to kind of prune down some of the third-party dependencies and just make it kind of ready to go in Android. I heard conditional updates, and that's all. Oh, batch updates? What about batch updates? Are they supported in the ObjectMapper? Yes. Question? Yeah, that's a good question. I think that's something that we could still provide as well at this point if we wanted to. We started with these just to see how it was going to work out. We didn't want to be limited by JPA or be forced to implement all of the JPA things, JPA functions. There are certainly some parts of JPA that don't make sense for Dynamo, so that's why we wanted to just be a little more explicit about that. Awesome.
Why did you guys choose JPA over JDO?
So we actually, so the question was, is this, are we compatible with JPA? Do we use JPA annotations? And the answer is we actually didn't choose JPA. We use our own annotations, so we're not really choosing JPA over JDO. Does that make sense? Awesome. So last but not least, oh, sorry, sir, yes?
Version integrity checking feature, does that work within a single JVM or across disparate clients?
That will work in an entire system over as many machines as you want. The client side is coordinating with the service side. The functionality, those conditions are applied on the service, so that's why it will work in a distributed system. Any more DynamoDB questions? Let's save to the end just so we can get through JavaMail, but I'm of course happy to answer them. So JavaMail, some of you might have heard of Amazon Simple Email Service. This launched a little while back, but it's been a really nice, simple service with a small API, very easy to use. And we wanted to expose this through the SDK, not only through the lower level client, but through something a little more familiar to developers. And this was really fun for us to build with JavaMail because it was such a great fit for a simple email service. So we chose to use JavaMail because it's a standard API, which we always like. Developers already know JavaMail. There's tons of documentation for it. There's great tutorials for JavaMail out there. So it was a really nice fit to bring the AWS APIs into JavaMail and enable people to start using the AWS APIs without even really having to learn the APIs and just use the APIs that they're already used to using. And we've got one more piece of code for you guys. This is just an example of how you can use the Amazon Simple Email Service in conjunction with JavaMail to send mail through the AWS platform. We need to set up a couple of session properties. We need to let the JavaMail system know that we're using the AWS JavaMail provider, setting the mail transport protocol, passing in our credentials, of course, so we can make those requests. And then from there, it's essentially using the JavaMail API, creating messages, setting the body and all the fields in the messages. And this is a really great way to use Simple Email Service, whether you want to send a couple of emails or thousands of emails. Simple Email Service really has a lot of strengths with bulk email sending, and JavaMail just fits really nicely with that as well. So thank you guys for coming. I hope that everybody learned at least one thing that they're able to take back and use to be more productive, to get more out of the SDKs. I would also really encourage you guys to connect with us, the AWS SDK developers, on the forums and other developers. We monitor the forums every day. We're active on there. We love talking to you guys. It's one of the big perks of our jobs is being able to connect with customers like that. And we take it very seriously. If you have problems, feedback, suggestions, we love hearing from people on the forums. A second, even another great way to connect with us is through our code on GitHub. All of the SDKs are completely open source. If you go to our GitHub page, you can find everything in the SDK, all the source code. You can find all the source code for the AWS Toolkit for Eclipse, and a ton of other really cool projects that we're working on in developer resources. So thanks again for coming. We still got a couple of minutes for questions.